Hello students, welcome back to our channel. We are discussing 10th class maths third chapter polynomials. So as in the part of this video, we are going to discuss the solutions of third bit problems in exercise 3.3. So now the third bit is given as find the quadratic polynomial for the zeros alpha beta given in each case. So here in this problem we will be given by the zeros of a quadratic polynomial, and using those zeros we need to find that quadratic polynomial. So let us see the first problem. 2 comma minus 1. Here 2 is the first zero and minus 1 is the second zero of a quadratic polynomial. Using these two zeros we need to find the quadratic polynomial. So let us take the first zero as alpha and second zero as beta. So here alpha equals to 2 and beta equals to minus 1. And now to find the quadratic polynomial, first let us find the sum of these two zeros. So sum of zeros, which can be represented with alpha plus beta, equals to here 2 plus minus 1. So whose sum equals to 1. So here we get the sum of the zeros, that is alpha plus beta equals to 1. Now let us do the product of the zeros, that is alpha into beta, which equals to alpha is 2 into beta equals to minus 1, and their product equals to minus 2. So now we have the sum of the zeros and the product of the zeros, and now we can able to find the quadratic polynomial since we have sum of zeros and the product of the zeros. And the formula for finding the quadratic polynomial is k into x square minus alpha plus beta into x plus alpha into beta. So in this formula, if we substitute alpha plus beta value and alpha into beta value, we get k into x square minus 1x plus minus 2, and by simplifying this expression we get k into x square minus x minus 2. So here if we take k value as 1, then we get the required polynomial value as x square minus x plus 1. So to find the quadratic polynomial, when we have two zeros, when we have two of its zeros, first we need to find the sum of the zeros and the product of the zeros, and then we use the formula k into x square minus alpha plus beta into x plus alpha into beta to find the required polynomial. Now let us see the second problem from this bit. So the second one is given as root 3 and minus root 3. So let us assume the first zero as alpha and the second zero as beta. Now let us find the sum of the zeros, that is alpha plus beta equals to root 3 plus minus root 3. So here by simplifying this we get alpha plus beta equals to 0, and the product of the zeros, that is alpha into beta equals to root 3 into minus root 3, and we get the product root 3 into minus root 3 equals to minus root 9, which is equals to minus 3. Now we have sum of the zeros and the product of the zeros. So now we can able to find the required polynomial using the formula k into x square minus alpha plus beta into x plus alpha into beta. So in this, if we substitute alpha plus beta as 0 and alpha into beta minus 3, we get k into x square minus 0 into x plus minus 3, and by simplifying this we get k into x square minus 3. Now here if we take k value equals to 1, then we get the polynomial as x square minus 3. Similarly, let us see the third problem. So here in the third problem, the two zeros are given as 1 by 4 and minus 1. So let us take the first zero as alpha and the second zero as beta. So here alpha equals to 1 by 4 and beta equals to minus 1. So next what we have to do? We have to find the sum of the zeros, that is alpha plus beta, which is equals to 1 by 4 plus minus 1, and by doing their sum we get minus 3 by 4. So alpha plus beta equals to minus 3 by 4. Now the product of the zeros, that is alpha into beta. So here the product of 1 by 4 and minus 1 we get minus 1 by 4. So alpha into beta equals to minus 1 by 4. Now we have alpha plus beta value and alpha into beta value. So we can find the quadratic polynomial. Further, the required formula is k into x square minus alpha plus beta into x plus alpha into beta. So in this formula, if we substitute alpha plus beta and alpha into beta values, we get k into x square minus 3 by 4x plus into minus 1 by 4. And by simplifying this expression, we get k into x square plus 3 by 4x minus 1 by 4. And here if we take k value as 4, and by simplifying this, we get the required polynomial as 4x square plus 3x minus 1. And the next problem, that is the fourth problem from third bit. Here the two zeros are given as 1 by 2 and 3 by 2, and let us take the first zero, that is 1 by 2, as alpha and the 3 by 2 as beta. Now let's find the sum of the zeros, that is alpha plus beta equals to 1 by 2 plus 3 by 2. So whose sum equals to 4 by 2, which equals to 2. So here the sum of the zeros is 2. And let's do product of the zeros, that is alpha into beta equals to 1 by 2 into 3 by 2, and whose product is 3 by 4. So now we have alpha plus beta as 2 and alpha into beta as 3 by 4. So we can find the required quadratic polynomial. So what is the formula for finding the quadratic polynomial when we have sum and the product of the zeros of a quadratic polynomial? Yes, that is k into x square minus alpha plus beta into x plus alpha into beta. And here if we substitute the corresponding values of alpha plus beta and alpha into beta, we get k into x square minus 2x plus 3 by 4. And by simplifying this, we get k into x square minus 2x plus 3 by 4. Here if we take k value as 4, and by substituting k equals to 4 and simplifying it, we get the required polynomial as 4x square minus 8x plus 3. So like this, when we have the two zeros of a quadratic polynomial, first we need to find the sum of the zeros and the product of the zeros. Then using the formula k into x square minus alpha plus beta into x plus alpha into beta, we can able to find the required polynomial. So this is all enough today. Let us meet in our next video. Till then, bye. Thank you.